Substituting a circuit breaker involves legality, compatibility, and safety considerations. According to the National Electrical Code, NEC, replacing a circuit breaker typically requires using the same brand and model as the original. However, there are exceptions. Firstly, when the original brand is no longer available. Secondly, when the replacement breaker has an identical or higher interrupting capacity. And thirdly, when the replacement breaker is specifically listed for use with the panel board. Compatibility is key. A General Electric G 2-pole 50 amps breaker may not be directly compatible with a Crouse Hinds panel board. The mounting dimensions and terminal configurations can differ, potentially making a safe and secure installation impossible. Therefore, directly substituting a G breaker for a Crouse Hinds breaker is generally not recommended without verifying compatibility and adherence to the NEC guidelines. If you cannot find an exact replacement from Crouse Hinds, some brands are commonly compatible with Crouse Hinds panel boards. These include Siemens, Square D, Eaton, Murray, and now TE. When choosing a substitute, several important considerations apply. Always consult the manufacturer's instructions for both the panel board and the replacement breaker. Ensure the replacement breaker has the correct amperage rating, which in the case is 50 amps. Verify that the interrupting capacity of the replacement breaker meets or exceeds the requirements of the electrical system. The interrupting capacity is the maximum fault current that the breaker can safely interrupt. Confirm that the tripping characteristics of the replacement breaker are appropriate for the circuit it will protect. Tripping characteristics define how quickly the breaker responds to overcurrent conditions. Also, make absolutely sure that the terminals of the replacement breaker are compatible with the panel board's bus bars. Bus bars are the conductive strips inside the panel board that distribute electricity to the breakers. Failure to follow these guidelines can result in significant electrical hazards, potentially leading to fire or electrocution. It is essential to prioritize safety during any electrical work. If you are unsure about replacing a circuit breaker or have any doubts about compatibility or safety, always consult with a qualified electrician. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and correctly. They can assess the specific situation, determine the appropriate replacement breaker, and ensure that the installation meets all applicable codes and standards. Remember that electrical work can be dangerous, and it's always best to err on the side of caution. Do not attempt to replace a circuit breaker unless you are confident in your ability to do so safely and correctly. The National Electrical Code, or NEC, provides a comprehensive set of standards for electrical installations. These standards are designed to ensure the safety of people and property. When substituting a circuit breaker, it is important to understand and comply with the relevant NEC requirements. The NEC Article 240 covers overcurrent protection, including circuit breakers and fuses. This article specifies the requirements for selecting, installing, and protecting overcurrent devices. Some key aspects of NEC Article 240 include: firstly, the ampere rating of a circuit breaker must be matched to the ampacity of the circuit conductors it protects. The ampacity is the maximum current that a conductor can carry continuously under specified conditions of use without exceeding its temperature rating. Secondly, the interrupting rating of a circuit breaker must be sufficient to interrupt the available fault current at its point of installation. The available fault current is the maximum current that could flow in a circuit during a short circuit condition. Thirdly, circuit breakers must be readily accessible and not exposed to physical damage. They should also be clearly labeled to indicate the circuits they control. In addition to Article 240, other NEC articles may be relevant to circuit breaker substitution depending on the specific application. For example, Article 408 covers switchboards and panel boards, which are the enclosures that house circuit breakers. Article 408 provides requirements for the construction, installation, and wiring of panel boards. It is important to consult the NEC and any other applicable codes and standards before replacing a circuit breaker. Local electrical codes may also have specific requirements that must be followed. Compatibility issues can arise when substituting circuit breakers. even if the replacement breaker has the same amperage rating and interrupting capacity as the original. Different manufacturers may use different mounting dimensions, terminal configurations, and bus bar designs. These differences can make it difficult or impossible to install a replacement breaker safely and securely. Therefore, it is generally recommended to use a circuit breaker from the same manufacturer as the panel board. This helps ensure that the breaker is compatible with the panel board's design and construction. If a direct replacement is not available, it may be possible to use a circuit breaker from another manufacturer, but only if it is specifically listed for use with the panel board. A listed circuit breaker has been tested and certified by a recognized testing laboratory to meet applicable safety standards. The listing mark on the breaker indicates that it has been evaluated for use in specific applications, including compatibility with certain panel boards. When selecting a replacement circuit breaker, it is also important to consider the type of circuit it will protect. Different types of circuits have different overcurrent protection requirements. For example, motor circuits require circuit breakers with inverse time characteristics, which means that the breaker's tripping time decreases as the overcurrent increases. This helps protect the motor from damage during starting and overload conditions. Other types of circuits, such as lighting and appliance circuits, may require circuit breakers with different tripping characteristics. It is important to select a circuit breaker that is appropriate for the specific circuit it will protect. Circuit breaker technology has advanced significantly over the years. Modern circuit breakers offer improved performance, reliability, and safety features. Some of the key advancements in circuit breaker technology include, firstly, electronic trip units, which use electronic sensors and microprocessors to detect overcurrent conditions and trip the breaker. Electronic trip units offer more precise and adjustable tripping characteristics than traditional thermal magnetic trip units. Secondly, arc fault circuit interrupters, or AFSIs, which are designed to protect against arc faults. Arc faults are dangerous electrical faults that can cause fires. AFSIs detect arc faults and quickly interrupt the circuit to prevent a fire from starting. Thirdly, ground fault circuit interrupters, or GFCIs, which are designed to protect against ground faults. Ground faults occur where electricity flows through an unintended path to ground. GFCIs detect ground faults and quickly interrupt the circuit to prevent electric shock. When replacing a circuit breaker, it may be beneficial to upgrade to a more advanced type of breaker, such as an AFSI or GFCI, to improve the safety of the electrical system. However, it is important to ensure that the new breaker is compatible with the existing panel board and wiring. The process of replacing a circuit breaker involves several steps. Firstly, turn off the power to the circuit breaker at the main disconnect switch. This will de-energize the circuit and prevent electric shock. Secondly, remove the panel board cover to access the circuit breakers. Be careful not to touch any exposed wires or terminals. Thirdly, identify the circuit breaker that needs to be replaced. Use a circuit tester to verify that the breaker is energized. Fourthly, loosen the screws that hold the breaker in place. Gently pull the breaker out of the panel board. Fifthly, install the new circuit breaker. Make sure it is properly seated in the panel board and that the screws are tightened securely. Sixthly, replace the panel board cover. Seventhly, turn on the power to the circuit breaker at the main disconnect switch. Eighthly, test the new circuit breaker to make sure it is working properly. Use a circuit tester to verify that the circuit is energized. If you are not comfortable performing these steps, it is best to consult with a qualified electrician. They can perform the replacement safely and correctly. Regular maintenance of circuit breakers is important to ensure their proper operation and safety. Circuit breakers should be inspected periodically for signs of damage or wear. Check for loose connections, cracked housings, and discolored components. Circuit breakers should also be tested periodically to verify that they are tripping properly. This can be done using a circuit breaker tester. If a circuit breaker fails to trip when it should be replaced immediately. In addition to visual inspections and testing, circuit breakers should also be kept clean and free of debris. dust, dirt, and other contaminants can interfere with the breaker's operation and reduce its lifespan. Circuit breakers should be cleaned regularly with a vacuum cleaner or a soft brush. Do not use water or other liquids to clean circuit breakers, as this could create an electrical hazard. In summary, substituting a circuit breaker requires careful consideration of legality, compatibility, and safety. Always consult the NEC and other applicable codes and standards. Choose a replacement breaker that is compatible with the panel board and has the correct amperage rating, interrupting capacity, and tripping characteristics. If you are unsure about any aspect of the replacement process, consult with the qualified electrician. Regular maintenance of circuit breakers is important to ensure their proper operation and safety. By following these guidelines, you can help ensure the safety and reliability of your electrical system. Also, be aware of series-rated breakers. A series rating is a short-circuit current rating applied to a combination of two or more overcurrent protective devices connected in series. This combination is used where the available fault current exceeds the interrupting rating of a downstream circuit breaker. If the series combination of circuit breakers is properly selected, the upstream circuit breaker will limit the let-through current to a value within the interrupting capability of the downstream breaker. The downstream breaker is still required to interrupt any overloads or low-level short circuits. A complete assembly of series-connected overcurrent protective devices is tested by the manufacturer to verify the series rating. Circuit breakers used in series combinations must be of the same manufacturer and type that was tested. The panel or equipment containing the series-connected circuit breakers must be marked with the series rating. Lastly, do not ever tamper with the circuit breakers.